So, sixth grade, we're going to talk about translations and rotations as some more transformations to be learned. This is chapter 8, section 7. So make sure you take notes on this and bring it to class to show me that you did it. So, a translation is a transformation that moves each point of a figure the same distance in the same direction. So the image is always congruent to the original image. And you'll find that all of these are congruent images. So basically, translation is sliding, either right and left or up and down or a combination of both. And I think of that as like a translation. You slide it into something else. Like I think, translating from one language to another, it makes it slide from one language to another language, and so they can understand it. So however you want to remember it is fine. But if you have certain translations, like if you slide to the right a specific amount, or in this case a units, then basically what you do is you take your x coordinate and you add the amount of units that you slid. If you slide to the left a certain amount of units, like a units, then you actually take your x coordinate and you subtract or make it, subtract that number of units also. Now if you slide up, we're going to say b units, if you slide up b units, then you're moving along your y axis, and so you will add that many units to your y coordinate. And if you slide down b units, then you would also subtract that many units from your y coordinate. Now let's take a look at an example. Here we go. Our original quadrilateral is in our black, EFGH, and you can see here that E, the coordinates are 1, 2, F is 4, 2, G is 3, 1, and H is 1, 1. And then you can see that we took this original and we translated or slid it over. So here you can see each point moved 4 units to the left and 2 units up. So you would write the translation xy as x minus 4 and y plus 2. So, for example, if you look at E, which is, we said 1, 2. So our x unit is 1, and if we subtracted 4 from that, we would say 1 minus 4 is a negative 3. And if you look here, we have negative 3 is where our E is. And then our Y, instead of 2, is plus 2. So 2 plus 2 is 4. So you can see that 4. So our E coordinate is now negative 3, 4. And if you did that with every single point, you will find that that is the correct unit. So again, if you look at F, it is 4, 2. Well, 4 minus 4 is 0. And if we have it again, Y is 2. And if you have 2 plus 2 is 4. And so again, 0, 4 is our F coordinate. G, we have 3, 1. So you have 3 minus 4 is negative 1, which is right here. And 1 plus 2 is 3, which is right here. And that's our coordinate for G. H is 1, 1. So 1 minus 4 is a negative 3. And 1 plus 2 is 3. And that's how you have all of your coordinates. And that is translation. Now we're going to talk about rotation. So, rotation. That is a transformation, like it says, that turns each point of a figure the same number of degrees around a common point. In this particular lesson, we will always be rotating around the origin. Remember our origin with our x and our y axes. So, a 90-degree clockwise rotation. What you do is you switch your coordinates, and then you multiply the new y coordinate by negative 1. So for example, if your point P is xy, then our rotated or image would be y, negative x. That would be our new coordinates. Here's an example. If your original coordinates were 6, 2, and you wanted to do a 90-degree clockwise rotation, your new one would be 2, negative 6. And you can see here that that is y, negative x. If you want to do a counterclockwise rotation, then you switch the coordinates and multiply the new x coordinate by negative 1. And again, remember, think of a clock. So this is going counterclockwise. So we're going in this direction. So again, if you have our coordinate, or our point P, which has the coordinates x, y, our image of P would be negative yx. For example, our point P is 5, 3. Our rotated image would be negative 3, 5. I'm going to show you some examples in just a second. And our last one is 180-degree rotation. With 180-degree rotation, you multiply both of its coordinates by negative 1. So if our point P is xy, then our image, our 180-degree rotated image, would be negative x and negative y. So if our point was 4, 1, then our image would be negative 4, negative 1. Let me show you some examples here. I'm going to take the screen off completely. So here we go. If this is our original, we're going to rotate this original quadrilateral, KLMN, 90 degrees counterclockwise. So I kept them here so you could see how I counterclockwise. I took my image and I turned it 90 degrees counterclockwise. So here you can see my original unit was 1, 1. Well, if we use the rule is to switch our x and y and then take our new x coordinate as a negative. So here it is, negative 1, 1 is our new k. Here, L is 3, 1. So our image of a 90-degree counterclockwise is negative 1, 3. So again, our negative, switch x and y, and then make your new x a negative. M is 2, 3. So our image is negative 3, 2. And N, the original, is 1, 3, and our image is negative 3, 1. So that's how we rotate a quadrilateral counterclockwise. Now if we showed, and you would do the opposite if it was clockwise. We'll do some in class with those. Now, here's one that's rotating our triangle FGH 180 degrees. So you can see here's our original triangle, FGH, and then our original, and this is our rotated, so we flipped it upside down 180 degrees. So on the original, remember with 180 degrees, you multiply both coordinates by negative 1. So F, our original, is negative 1, 1. Our image is now 1, negative 1. And you can see right here. G, 0, 3. 0 is still 0, but it goes to negative 3. And H, 3, 1 is negative 3, negative 1. So that's the lesson, and we will do some examples in class tomorrow. Have a great night.